So this is the inside of a lithium iron phosphate battery pack that I designed. So there's a lot of systems in here. The main ones are the batteries. So these are the battery cells, and there's 2 of them. And these are LiFePo4, the new lithium, less energy density, but fairly flat discharge discharge rate versus capacity, which is very interesting. So these systems require a battery management. These batteries require a battery management system, which is this computer over here. This computer monitors the pack cell, every single individual pack, and it monitors both the voltage and temperature. And there's computers on every cell, and they are across the 2 terminals. So all these computers talk to each other via these wires, and then they talk to the main battery management system. That system has a nice little display up here, which we can turn on, and it gives you diagnostics information on the battery. So not only do you have voltage and temperature, but you also have current sensing across the entire pack, and that is done by this current shunt over here. So this measures the voltage dropped across here and gives you your current draw. So there's a lot of wiring that needs to be done to handle all these different systems, and there's also a computer that I use, which is an Arduino, to interface this whole entire battery management system to another master computer that can be located anywhere via serial. And so there's 2 types of wiring. There's the power wiring, and then there's a lot of data wiring over here. This is a DC-DC converter that converts the battery power to a flat 12 volts that powers the battery management system. And if you take the top off, so this is the back panel, and this is the main. These are the 3 circuits I have, and they're all fused, and this is all kind of heavy gauge wire, and there's also a main fuse over here, and this fuse is a big one, so 200 amp fuse, and this is rated for 200 amp continuous, kind of continuous discharge, 100 to 200, continuous, with 200 being your kind of max continuous. But you shouldn't really see that kind of draw, at least on my system. But everything's rated for that. All the wires are the right thickness for that current discharge, and then that's going into nice terminal blocks that your circuits can connect to. Now, the interesting about this whole system is that it's waterproof. It goes into a Pelican case that's over here, and it's fully enclosed, which is the challenge. So that's why I had to build the chassis that goes into there.